So welcome all of you. So this is the third video of chi-square test problem. Okay, so here the question is, a die is thrown 132 times with the following results. Number turned up 1, 2, 3, 4, 5 and 6, and the frequency with which number 1 turned up is 16, number 2 is 20, number 3 is 25, number 4 is 14, number 5 is 29 and 6 is 28. The question is the die unbiased? That is the question. Is the die unbiased? So once again, here a die is thrown 132 times and number turned up. Here you can see 1, 2, 3, 4, 5, 6. Then number 1, 6, frequency is 60. Number 2, frequency 20. Number 3, frequency is 25. Number 4, frequency 14. Number 5, frequency is 29. And number 6, frequency is 28. The question is the die unbiased? Is the die unbiased? So here let us take the hypothesis that the die is unbiased. I am taking the hypothesis as the die is unbiased. Okay. So I will take the whiteboard. Okay. So I will, yeah. So the hypothesis as die unbiased. Die unbiased. Okay. If that is the case, then what is the probability of obtaining any one of the 6 numbers? So what is the probability? Probability of obtaining any one of 6 numbers. Obtaining any one of 6 numbers. Obtaining any one of 6 numbers. That is equal to 1 by 6. This is the probability. Because the die is unbiased. If the die is biased, this is not the condition. So here the die is unbiased. That means the probability of obtaining any one of 6 numbers is 1 by 6. Then what is the expected frequency? You have to calculate the expected frequency. Okay, so expected frequency is die is turned 132 times. Die is thrown 132 times. So into the probability of obtaining any one of 6 numbers is 1 by 6. So the expected frequency will be 22. The expected frequency will be 22. So 132 into 1 by 6, that is equal to 22. Then you have to draw the table. Okay. So the first column, that is number turned up. Number turned up. Okay. So you know 1, then 2, then 3, 4, then 5 and 6. Okay, number turned up. Then observed frequency, say I will write OI. OI, this is the observed frequency. So observed frequency is actually given. What is the observed frequency? So number 1, the observed frequency is 16. Number 2, the observed frequency is 20. It is already given in the question, 20. Then 3, that is 25. Then 4, it is 14. And 5, it is 29. Okay. And number 6, that is 28. Then the next column, that is the expected frequency. So I will write here EI. EI, expected frequency. What is the expected frequency? So expected frequency means here you have calculated the expected frequency. Here the die is unbiased, so the probability of obtaining any one of 6 numbers is 1/6. Then the expected frequency is die is thrown 132 times, so 132 multiplied with the probability of obtaining any one of 6 numbers is 1/6. That is 132 into 1/6, that is 22. So the expected frequency of 1 is 22, expected frequency of 2 is 22, expected 3 is 22, expected frequency of 4 again 22, 5 expected frequency of 5 is 22, expected frequency of 6 is 22. Okay, then the next thing is you have to calculate OI minus EI. You have to calculate OI minus EI. Okay, calculate OI minus EI. So what is the difference? 16 minus 22, that is equal to minus 6. Then 20 minus 22, that is minus 2. Then 25 minus 22, that is 3. Then 14 minus 22, that is minus 8. Then 29 minus 22, that is equal to 7. Then 28 minus 22, that is equal to 6. Then what is the next step? That is you have to square it. OI minus EI, OI minus EI the whole square, OI minus EI the whole square. You have to calculate OI minus EI the whole square, that is 6 square, that is 36. Then 2 square 4, 3 square 9, 8 square 64, then 7 square 49, and 6 square, that is 36. Then the last step is OI minus EI the whole square divided by expected frequency, that is EI. Okay, so here you can see this is 36 divided by 22. Then this is 4 divided by 22. Then here this is 9 divided by 22. This is 64 divided by 22. 49 divided by 22. 36 divided by 22. Okay, so this is the OI minus EI the whole square divided by EI. Okay, so our equation of chi-square is like this. So chi-square is equal to sigma OI minus EI the whole square divided by EI. Okay, so you know all these values, you have to add these. Okay, you have to add all these values, you will get the chi-square value. So the chi-square value is that is equal to, you will get 9. So this is the calculated value. This is 9 and this is the calculated value. Then you have to find the table value of chi-square. So for that you need the degree of freedom and the level of significance. So here level of significance is not given, so you can assume the level of significance value as 5%. Then degrees of freedom, that is equal to n minus 1. So here n is equal to 6. So 6 minus 1, that is equal to 5. So what is the value of chi-square table value? Okay, so I will share the here you can see this is the critical values of chi-square. So the level of significance is 5%. So here this is the level of significance, that is 5%, and the degrees of freedom is 5. So this is degrees of freedom. So you have to calculate the value. Yeah, this is the value. Level of significance is 5%. So the value is 11.070. 11.070. So the table value is 11.071. Okay. Then you have to compare the stable value with the calculated value. So you can see the chi-square table value is here. You can see the chi-square table value is greater than chi-square calculated value. So that means the hypothesis, you accept the hypothesis. Accept hypothesis. Accept the hypothesis. Accept that means the die is actually unbiased. Okay, so the die is unbiased. I hope this problem is clear. Okay, thank you.